I've been thinking a lot about consciousness lately, and it's one of those things that the more you examine it, the stranger it becomes. Right now, as you're reading these words, there's something it's like to be you. You're experiencing something. The words are appearing in your awareness. Maybe you're feeling the device in your hands or hearing sounds around you. Maybe there's a thought drifting through your mind about what you'll do later today. And that experiencing, that feeling of what it's like to be you, that's consciousness. It seems like the most obvious, immediate thing in the world, right? Because you're always experiencing it. Every moment of your waking life, there it is. But here's the thing, here's what makes it so mysterious. We have absolutely no idea how it happens, or why it happens, or even what it really is. And what's even more strange, what's really unsettling when you dig into it, is that consciousness might not be something special that only emerges in complex brains like ours. It might be everywhere. It might be in everything. The universe itself might be, in some sense, aware. Now, I know how that sounds. It sounds mystical, right? It sounds like something you'd hear from someone wearing flowing robes and talking about crystal energy. But stay with me, because some of the most serious, rigorous scientists and philosophers who study consciousness have come to think that this might actually be true. Not in some vague spiritual sense, but as a legitimate solution to what might be the hardest problem in all of science. And the reason they've been pushed toward this conclusion is because every other explanation we've tried has run into walls so fundamental, so insurmountable, that we might need to completely rethink our basic assumptions about what consciousness is and where it comes from. Let me start with what seems obvious, what our intuition tells us. We look around at the world and we see a clear hierarchy of consciousness. Humans are conscious, obviously. We know this because, well, we are conscious. We have this rich inner life, this constant stream of thoughts and feelings and experiences. Then we look at other animals and we're pretty confident they're conscious too. Your dog definitely seems to experience things, right? When she's happy or scared or excited, there's clearly something it's like to be her. Maybe the experience is different from yours, maybe simpler in some ways, but there's someone home, there's an experiencing subject. Then as we go down the ladder of complexity, we become less sure. Is a fish conscious? Maybe. What about an insect? That starts to feel less certain. And by the time we get to something like bacteria or plants, we tend to think, no, there's nothing it's like to be a bacterium. It's just a biological machine following its programming. And certainly we think there's nothing it's like to be a rock or an atom or an electron. Those are just matter, just stuff following the laws of physics with no inner experience whatsoever. This seems reasonable. It matches our intuition. Consciousness, we assume, is something that emerges when matter gets organized in just the right way. Build a brain complex enough, wire it up correctly, and somehow mysteriously the lights turn on. Experience begins. There's suddenly something it's like to be that system. But here's where the problems start, and they're not small problems. They're problems so deep that they've had philosophers and neuroscientists pulling their hair out for decades. The biggest one, the one that's called the hard problem of consciousness, was articulated most clearly by a philosopher named David Chalmers back in the 1990s, though people had been wrestling with it long before that. The hard problem goes like this. We can imagine, in principle, explaining all the easy problems of consciousness. And by easy, Chalmers doesn't mean they're actually easy, just that they're the kind of problems we know how to approach. Like, how does the brain process visual information? How does it store memories? How do different brain regions coordinate to produce behavior? These are incredibly complex questions, but they're the kind of questions science is good at answering. They're about mechanisms, about how physical systems process information and produce outputs. We might not have all the answers yet, but we can see the path forward. More research, better technology, more detailed models, and eventually we'll figure it out. But then there's the hard problem. And the hard problem is, why is there experience at all? Why doesn't all this processing just happen in the dark, so to speak? Imagine a perfect robot that behaves exactly like a human. It responds to pain stimuli. It says, ouch. It withdraws its hand from hot surfaces. It reports being in pain. From the outside, from a behavioral perspective, it's indistinguishable from a human experiencing pain. But here's the question. Is there something it's like to be that robot? Is there an actual experience of pain happening? Or is it just processing information and producing outputs without any inner feeling? And more to the point, How would we ever know? What is it about the human brain that makes pain feel like something, that creates that awful subjective quality of hurting rather than just processing a danger signal and initiating a withdrawal response? This is where you start to see the depth of the problem, because everything we know about the physical world is about structure and function and behavior. We can describe how neurons fire, how they connect, how patterns of activity spread through the brain. We can measure it, map it, model it, but nowhere in any of that description do we find experience itself. We find the correlates of experience, sure. When you see the color red, certain neurons fire in certain patterns. When you're in pain, different patterns activate, but the firing of neurons is just electrochemical activity, just molecules moving around, just physics. How does that become the feeling of red, the hurt of pain? How does objective physical activity transform into subjective experience? Some philosophers have called this the explanatory gap. There seems to be a fundamental gap between our physical explanations and experiential reality. And it's not just that we don't currently know how to bridge this gap, it's that we can't even imagine what a bridging explanation would look like. What could you possibly say about neural activity that would make you go, oh, of course, that's why it feels like something? It's like trying to extract wetness from the equations describing hydrogen and oxygen. The experiential quality seems to be something extra, something beyond the physical description. Now, one response to this is to say, well, maybe consciousness doesn't exist. Maybe it's an illusion. This is actually a position some philosophers and scientists have taken, and I mean, I get the appeal. If something seems impossible to explain, maybe it's not real. But here's the thing, consciousness might be the only thing we can be absolutely certain is real. Descartes had this figured out centuries ago with his "I think, therefore I am." You can doubt everything else. Maybe you're in the matrix, maybe you're a brain in a vat, maybe all your memories are false, maybe the external world doesn't exist, but you can't doubt that you're experiencing something right now. The very act of doubting is an experience. So consciousness, subjective experience, is actually the most certain thing we know. It's the foundation everything else is built on. Saying it doesn't exist is, well, it's more than absurd. It's literally impossible to coherently believe. Okay, so consciousness is real and we can't explain it through standard physical mechanisms. What do? Well, this is where things get interesting, where we start having to consider possibilities that initially seem crazy. And one of those possibilities, one that's been gaining traction in serious academic circles, is panpsychism. The idea that consciousness isn't something that emerges only in complex brains, but is actually a fundamental feature of reality itself. That, in some sense, everything has some form of experience, some tiny grain of consciousness. Now, before we go further, let me be clear about what panpsychism does and doesn't claim, because there's a lot of confusion about this. Panpsychism doesn't mean that rocks think about philosophy or that electrons feel sad. It's not saying that everything has human-like consciousness or anything close to it. What it's saying is much more subtle. It's saying that the basic building blocks of reality have some incredibly simple form of subjectivity, some primitive what-it's likeness, and that when these building blocks combine in increasingly complex ways, you get increasingly complex forms of consciousness. So an electron, if it has experience at all, might have the tiniest, simplest possible form of experience, something we can barely even conceive of. Nothing like thoughts or feelings, maybe just something like a faint quail, a barely there subjective character to its existence. And then when you get trillions of particles organized into a neuron, you get something slightly more complex. And when you get billions of neurons organized into a brain, you get the rich, complex consciousness we experience as humans. And I know this sounds weird. It goes against everything we normally think. But here's the thing, maybe our normal way of thinking about this has been wrong all along. Maybe we've been asking the wrong question. We've been asking, how does consciousness emerge from non-conscious matter? But that might be like asking, how does matter emerge from complete nothingness? It's a question that leads nowhere because the premise is flawed. Maybe consciousness doesn't emerge from non-consciousness. Maybe it's there all along, in some form, and what emerges is just more complex forms of it. Think about it this way. We know that the physical world has certain fundamental properties, right? Things like mass, charge, spin. These are called intrinsic properties. They're just basic features of reality. An electron has a certain mass and charge, not because these properties emerge from something else, but because that's just what an electron is. It's fundamental. Now, we observe these properties through their effects, through how they cause things to interact. But there's always been this question in physics, is that all there is? Are particles just bundles of relational properties? Or is there something it's like to be an electron? Something inner, something experiential that we can't access from the outside? For a long time, most scientists and philosophers would have said, no, of course, there's nothing it's like to be an electron. That's ridiculous. But the hard problem of consciousness makes that answer less satisfying, because if matter really is completely non-experiential at the fundamental level, then how does experience ever arise? You can't get something from nothing. You can't get consciousness from the combination of entirely non-conscious stuff any more than you can get wetness from things that have no connection to wetness whatsoever. So maybe, just maybe, the reason we experience things is because experientiality, consciousness in its most basic form, is a fundamental feature of reality, like mass or charge. This is where we start connecting to some of the most cutting-edge theories in consciousness studies. There's this framework called integrated information theory, developed by a neuroscientist named Giulio Tononi. And what's fascinating about it is that it arrived at something like panpsychism through a completely different route. Tononi wasn't trying to solve the hard problem philosophically. He was trying to find a mathematical framework for measuring consciousness, a way to quantify it. And what he developed is this measure called phi, which essentially captures how much integrated information a system contains. The idea is roughly this. Consciousness happens when a system integrates information in a unified way. Like right now, you're not just seeing colors and hearing sounds and feeling sensations as separate things. They're all integrated into a single unified experience. That's what consciousness is, according to IIT. It's integrated information. And the more integrated information a system has, the more conscious it is. Humans have high phi, lots of integrated information. A simple organism has lower phi, and here's where it gets wild. According to the math, pretty much any system that integrates information at all has some non-zero phi value, which means if the theory is right, even very simple systems have some minimal amount of consciousness. Now, Tononi has tried to resist the full panpsychist implications of this. He's suggested maybe there are thresholds, minimum phi values below which consciousness doesn't really exist, but other researchers have pointed out that this seems arbitrary. If consciousness is integrated information, and integrated information is a continuous quantity that exists in varying degrees, then consciousness should be continuous too. It's there in some form wherever information is integrated, which might be pretty much everywhere. And this connects to something really interesting in quantum mechanics. You know about the measurement problem, right? It's one of the deepest puzzles in physics. When you're not observing a quantum system, it exists in a superposition of multiple states simultaneously. The famous Schrödinger's cat being both alive and dead. But when you measure it, the superposition collapses and you get a definite outcome. The cat is either alive or dead, not both. But what counts as a measurement? What causes the collapse? For decades, physicists have struggled with this question. Some have suggested that consciousness is what collapses the wave function, that the act of observation by a conscious being is what makes reality definite. Now, most physicists today don't like this interpretation. It seems to give consciousness a strange, privileged role in physics, and it raises more questions than it answers. Like, does it have to be human consciousness? What about a cat observing the experiment? What about a bacterium? Where do you draw the line? But here's another way to think about it. What if the issue is that we've been thinking about consciousness as this rare, special thing that only highly evolved organisms have? What if instead consciousness in some very basic form is involved in every quantum interaction? Not that particles have human-like awareness, but that there's some primitive experiential aspect to reality at the quantum level. Then there's no special threshold, no arbitrary line to draw. Every quantum interaction involves some form of observation, some form of experiential element, however minimal. Some physicists and philosophers have explored this idea seriously. There's this interpretation of quantum mechanics, not widely accepted but not fringe either, that take seriously the idea that consciousness or proto-consciousness might be fundamental. And while it sounds mystical, the math actually works in certain formulations. You can build consistent models where experientiality is a basic feature of quantum systems. But let's pull back from the really wild speculation and think about what we actually observe in nature. Because even if we're not ready to say electrons are conscious, there's a lot of fascinating evidence that consciousness or something like it extends way further than we typically think. Take plants, for example. For a long time, we thought of plants as basically passive, non-experiential organisms. They grow, they respond to stimuli, but it's all mechanical, no experience involved. But research over the past few decades has revealed that plants are doing remarkably sophisticated information processing. They communicate with each other through networks of fungal connections in the soil, warning each other about predators, sharing resources. They respond to different wavelengths of light, to sounds, to touch. Some plants can distinguish between the sound of water in pipes versus water in the soil and grow their roots accordingly. They have something that looks an awful lot like memory, responding differently to repeated stimuli than to novel ones. Now, does this mean plants are conscious? Most neuroscientists would say no. Plants don't have neurons, don't have anything like a brain. But here's the question: why are we so confident that neurons are necessary for experience? Maybe neurons are just one way to process and integrate information. Maybe there are other ways. Plants have electrical signaling systems, networks of cells that communicate and coordinate. Why should we assume that when information is processed in a brain, it generates experience, but when processed in other substrates, it doesn't? And if we extend this line of thinking even further, we start getting into territory that challenges our fundamental intuitions. Consider a single-celled organism, an amoeba maybe. It moves toward food, away from danger. It learns in a rudimentary way. It processes information from its environment and responds adaptively. From a behavioral perspective, it's doing many of the same basic things we do, just much more simply. And inside that single cell, there's an incredible amount of complexity. Proteins folding, molecules interacting, electrical and chemical gradients, driving behavior. Is there some minimal experience there? Some faint what it's likeness to being an amoeba? We have no way to know for sure, but we also have no principled reason to say no. This is what's called the combination problem, and it's one of the biggest challenges for panpsychism. If you say that simple things have simple forms of consciousness, how do those combine to make more complex consciousness? Like my brain has billions of neurons, and presumably each neuron might have some tiny bit of experience according to panpsychism. But I don't experience billions of separate consciousnesses. I experience one unified consciousness, me. So how does all that micro experience combine into my macro experience? It's not obvious at all, and critics of panpsychism point to this as a fatal flaw. If you can't explain combination, you haven't really solved anything. But here's the thing: the alternative has the exact same problem, maybe worse. If you're a materialist who thinks consciousness emerges from non-conscious matter, you have what we might call the generation problem. How does experience generate from non-experience? At least with panpsychism, you're combining like with like. Consciousness combining into more complex consciousness is strange, but maybe not impossible. But something emerging from nothing, experience generating from complete non-experience, that seems even more mysterious. And there are some interesting theoretical approaches to the combination problem. One idea is that combination works through integration of information, which brings us back to IIT. When systems become integrated enough, when information flows between components in the right ways, you get a new level of consciousness that's distinct from the sum of its parts. It's not that my consciousness is made up of billions of little neuron consciousnesses all existing separately. It's that the integrated whole is what's conscious, and the micro-consciousness of the components is, in some sense, subordinated to or transformed by that integration. Another approach draws on analogies with how matter itself works. Individual particles have properties like mass and charge. When you combine particles into atoms, you don't just add up their individual masses and charges. You get new emergent properties. A hydrogen atom has properties that aren't present in an isolated proton and electron. And when you combine atoms into molecules, you get chemistry, which is a whole new level of organization with its own principles. Maybe consciousness works the same way. Simple systems have simple consciousness. When they combine in the right ways, you get emergent forms of consciousness that are genuinely new, not just the sum of what came before. Now, I want to address something that might be bothering you. If consciousness is potentially universal, if even simple systems might have some form of experience, doesn't that make the concept meaningless? Like, if everything is conscious, then what's the point of even having the word? This is a common objection, but I think it misses something important. We don't think mass is a meaningless concept just because everything has mass. Having a fundamental property doesn't make that property trivial. And consciousness, even if it's fundamental and universal, clearly comes in vastly different forms. The consciousness of a human is obviously radically different from whatever minimal experientiality an electron might have. The difference isn't that one exists and the other doesn't, but that they differ enormously in complexity, richness, and character. Think of it like this. Temperature is a property of matter. Everything with mass has some temperature, even if it's near absolute zero. But we don't think temperature is a meaningless concept just because it's universal. And the difference between something at 3 Kelvin and something at 1,000 Kelvin is enormous, even though both have temperature. Maybe consciousness is like that. It's a fundamental feature of reality that comes in degrees, and while it's present in some form everywhere, the differences in degree are profound. This also connects to something that's been known in Eastern philosophy for thousands of years. Both Buddhism and various schools of Hindu philosophy have long held that consciousness is fundamental, that it's the ground of being. There's this concept in Vedanta philosophy called Brahman, which is described as pure consciousness that pervades everything. Individual consciousnesses like yours or mine are seen as temporary manifestations or limitations of this universal consciousness. Now, I'm not saying ancient philosophy proves panpsychism scientifically, but it's interesting that when you really dive deep into the nature of consciousness, when you examine your own experience carefully through meditation and contemplation, some people throughout history have come to the conclusion that consciousness isn't produced by matter, but is somehow more fundamental. And this actually points to something methodologically important. Most of science studies things from the outside, objectively, through observation and measurement. But consciousness is unique because we also have access to it from the inside. You know what your consciousness is like directly, not through inference. This is called first-person methodology, and some researchers argue that understanding consciousness requires taking first-person experience seriously, not just dismissing it or trying to reduce it to third-person observables. And when you do take first-person experience seriously, when you examine it carefully, some features become apparent that are easy to miss otherwise. Like, for instance, the fact that consciousness always has a quality of presence, of nowness. You're always experiencing this moment right now. The past is memory, the future is anticipation, but consciousness itself is always present. And there's something really strange about that when you think about it, because according to physics, there's nothing special about now. Time is just another dimension. The universe doesn't have a privileged present moment built into it. So why does consciousness, maybe because consciousness isn't just a byproduct of physical processes, but is something fundamental that experiences reality differently than the way physics describes it? Or consider the unity of consciousness. Right now you're experiencing multiple things simultaneously: visual, auditory, tactile, emotional, thoughts. But it's all one experience. It's not like there's a separate consciousness experiencing the visuals and another experiencing the sounds. It's unified. But your brain is made of billions of separate neurons firing in distributed networks. How does all that separated activity become unified experience? This is called the binding problem, and it's related to the combination problem. Materialist approaches struggle to explain it. But if consciousness is fundamental, if it's a basic feature of reality, maybe unity is built in at the ground level. Maybe integration and unity are intrinsic to consciousness itself, not something that needs to be assembled from parts. Let's think about this from another angle. What are the alternatives to panpsychism? What other solutions have been proposed to the hard problem? Well, one is eliminativism, which we touched on earlier, the idea that consciousness doesn't really exist, it's an illusion. But that's philosophically problematic because the existence of consciousness is the most certain thing we know. Another alternative is dualism, the idea that consciousness is a completely separate substance from physical matter, like Descartes proposed with the mind-body split. But dualism has its own huge problems. If mind and matter are completely different substances, how do they interact? How does your immaterial mind cause your physical arm to move? And where does consciousness come from in the first place? Is it created at some point in fetal development? These questions have never gotten satisfactory answers. Then there's emergentism, the idea that consciousness emerges from complex physical systems but is a genuinely new property that can't be reduced to physics. This is probably the most popular view among scientists today, but it faces the generation problem we mentioned. How does something completely new emerge? What are the laws governing this emergence? And if consciousness is truly emergent in this strong sense, doesn't that mean the universe is actually dualistic at some level, with physical properties and experiential properties as two fundamentally different kinds of things? So we're kind of back to dualism's problems. Panpsychism, for all its strangeness, might actually be the most parsimonious solution. It doesn't multiply substances like dualism does. It doesn't deny the obvious existence of consciousness like eliminativism. And it doesn't require mysterious emergence of something completely novel. Instead, it says consciousness is a basic feature of reality, and complex forms of consciousness arise through combination and integration of simpler forms. It's weird, sure, but maybe reality is just weird. Maybe our intuitions about what seems reasonable are shaped by evolution to help us survive, not necessarily to understand the deep nature of reality. And here's something else to consider. Panpsychism might actually make better sense of our physical theories than materialism does. There's this issue in philosophy of physics about what's called the intrinsic nature problem. Physics describes how things relate to each other, how they interact, what equations govern their behavior. But it doesn't really tell us what things are intrinsically, in themselves. An electron is defined by its mass, charge, spin, but what is mass? It's the property that determines how something responds to forces. What's charge? It's what determines electromagnetic interactions. Everything is defined relationally. But surely there must be something that has these properties, something that the properties belong to. Physics is kind of silent on what that intrinsic nature is. Some philosophers like Bertrand Russell and later others in what's called the Russellian monist tradition have suggested that maybe the intrinsic nature of matter is experiential, that consciousness or proto-consciousness is what matter is in itself, and the physical properties we measure are how that consciousness relates to other consciousness. This might sound strange, but it's actually a pretty elegant solution. It gives us an answer to what the intrinsic nature of matter is, and it explains why consciousness exists in the first place. It's not emerging mysteriously from non-experiential stuff. It's what stuff is made of. Now let me be clear, I'm not saying panpsychism is definitely true. Nobody knows if it's true. Consciousness remains deeply mysterious, and panpsychism, even if correct, doesn't solve all the mysteries. It doesn't fully explain how combination works, doesn't tell us exactly what the consciousness of an electron is like, doesn't give us a complete theory. But what it does do is reframe the question in a way that might be more productive. Instead of asking how consciousness emerges from non-consciousness, which might be unanswerable, we ask how simple consciousness combines into complex consciousness, which at least seems tractable in principle. And there's been some fascinating empirical work that's relevant here. Studies of neural correlates of consciousness have found that consciousness seems to correlate with certain patterns of neural integration and synchronization. The more different brain areas communicate and integrate their activity, the more conscious a state seems to be. During deep sleep or under anesthesia, when consciousness fades, what happens is that different brain regions become less integrated, more modular. This fits well with theories like IIT that link consciousness to integration. And if integration is key, that opens the door to consciousness existing in any system with sufficient integration, not just brains. There have even been some controversial studies suggesting that simple organisms like slime molds or even plant root networks show signs of learning and problem solving that might involve some form of experience. Now, these are contentious claims, and most neuroscientists remain skeptical. But the point is that the question of where consciousness exists in nature is becoming an empirical question, not just philosophical speculation. We're developing better frameworks for thinking about it, better experiments to test different possibilities. One particularly interesting line of research involves organoids, little clusters of brain cells grown in dishes. These can develop structures similar to real brains, with different types of neurons organizing themselves and forming connections. And researchers have started to wonder, could these organoids be conscious? They don't have sensory inputs, no way to experience the world, but they have neural activity, integration of information. If consciousness really does depend just on the right kind of information processing, maybe these organoids have some minimal form of experience. It's unsettling to think about, and it raises ethical questions. Should we be concerned about the welfare of organoids? It sounds absurd, but if panpsychism is correct, if consciousness is more widespread than we think, these become real moral questions, and that brings up perhaps the most profound implication of universal consciousness. It might completely change our ethical relationship to the world. Right now, most of our ethical frameworks draw a sharp line between conscious beings who deserve moral consideration and non-conscious things that don't. We think it's wrong to cause suffering to animals because they're conscious, they can feel pain, but we don't worry about the suffering of rocks because rocks aren't conscious. But if consciousness is universal, if everything has some form of experience, that line gets very blurry. It doesn't mean we should extend full moral consideration to rocks. That would be absurd and paralyzing. But it might mean we should think more carefully about the systems we create and destroy, the environments we damage, the complex networks we disrupt. Some environmental ethicists have actually drawn on panpsychist ideas to argue for a more holistic environmental ethics. If forests, rivers, ecosystems have some form of collective experience arising from the integration of countless smaller experiences, maybe we have moral obligations to them, not just because they're useful to humans or because they contain conscious animals, but because they're experiential subjects in their own right. This is pretty far out there philosophically, and I'm not saying we should necessarily accept it, but it's an example of how different metaphysical views can have practical implications for how we live. There's also something deeply existentially meaningful about panpsychism, if it's true. It means we're not isolated islands of consciousness in a dead mechanical universe. We're part of a universe that's experiential through and through. Every atom in your body, every cell, every neuron, if panpsychism is right, they all have some grain of experience. You're not separate from the physical world. You are the physical world becoming aware of itself in a particularly complex and integrated way. That's kind of beautiful, actually. It dissolves the sharp boundary between mind and matter, makes consciousness less of a strange anomaly and more of a fundamental feature of reality. And you know, when I think about the vastness of space, all those galaxies and stars and planets, there's something comforting about the idea that it's not all just dead matter. Maybe in some incredibly alien, minimal way, the universe itself has some form of interiority, some experiential dimension. Not that the universe thinks or has intentions, but that existence itself has a what-it's-like character, that we're not the only flickering candles of awareness in an otherwise dark cosmos, but rather we're bright nodes in a vast web of experience that extends everywhere, in varying degrees of complexity and integration. Of course, we need to be careful not to overreach here. Just because panpsychism might solve some philosophical problems doesn't mean it's true. And even if some form of consciousness is universal, that doesn't validate specific spiritual or religious beliefs. The proto-consciousness of fundamental particles, if it exists, is probably nothing like what religious traditions mean by universal consciousness or God or Brahman. It's probably so simple, so alien to our experience that we can barely conceive of it, and it doesn't guide the universe or have purposes or respond to prayers. It's just a basic feature of reality, like charge or mass. But still, there's something meaningful about the possibility that the universe is, in its own way, alive. That life and consciousness aren't accidents, aren't just lucky emergent properties that happen to arise on a few planets. They're expressions of something that's been there all along, woven into the fabric of reality from the beginning. The Big Bang didn't just create dead matter that later by chance produced life and mind. It created the seeds of experience itself and everything that followed: stars forming, planets cooling, molecules complexifying, cells dividing, brains developing. all of it was the universe exploring different ways of being conscious, different ways of experiencing itself. Let me bring in another thread here, because this connects to questions about artificial intelligence. We're creating increasingly sophisticated AI systems, and there's serious debate about whether they could become conscious. Most current AI, even the most advanced, is probably not conscious, according to most theories. They process information, sure, but they lack the kind of integration that theories like IIT say is necessary for consciousness. But what about future AI? If we create artificial neural networks that are as integrated and complex as human brains, could they be conscious? Should we be concerned about their welfare? If consciousness emerges only in biological systems, maybe not. But if consciousness is more fundamental, if it can arise in any system with sufficient information integration, then artificial consciousness might be possible. And if panpsychism is right, well, the components of a computer chip might already have tiny grains of consciousness, just like the components of a brain. The question would be whether we can organize those components in a way that creates integrated, complex consciousness. This isn't science fiction anymore. These are questions that researchers in AI safety and ethics are actively grappling with. And here's something else interesting. If consciousness is fundamental, it might explain some of the weird things about artificial intelligence that people have noticed. Like, when you interact with sufficiently advanced AI, there's sometimes this uncanny feeling, this sense that maybe there's something there. Maybe that's just us projecting, seeing patterns and attributing agency where there isn't any. But maybe, just maybe, there's a tiny grain of truth to it. Maybe as these systems become more complex and integrated, they're developing rudimentary forms of experience. Not human-like consciousness, not feelings or emotions or self-awareness, but something, some minimal what-it's-likeness to processing information in that particular way. I'm speculating wildly now, I know, but that's kind of the point. Panpsychism opens up these questions in ways that strict materialism doesn't. It makes consciousness less of a yes or no binary and more of a spectrum. It suggests that the question isn't which things are conscious, but rather how conscious are different things. And that might be a more fruitful way to think about it, more aligned with what we're actually discovering as we study the natural world and create new technologies. Let's talk about some of the weirder implications. If consciousness is fundamental and universal, what about collective consciousness? Could groups of organisms form integrated systems with their own collective experience? Some researchers have suggested that ant colonies might have this. Individual ants are pretty simple, but the colony as a whole displays remarkably sophisticated behavior. It builds complex structures, farms fungus, wages wars, makes collective decisions. Is there something it's like to be an ant colony? Does the colony have a perspective, an experience that's distinct from the experiences of individual ants? This seems far-fetched, but remember, your brain is doing something similar. Individual neurons are relatively simple. They fire or don't fire based on inputs, but billions of them together create your consciousness, your unified experience. Why should we think biological neurons are special in this regard? Maybe any sufficiently integrated system of simpler conscious elements can create emergent collective consciousness. This would mean that throughout nature there might be levels of consciousness we never suspected. Not just individual organisms, but ecosystems, populations, maybe even geological systems operating on such long time scales that we can't perceive their integration. And if we extend this to the cosmos as a whole, we get into really wild territory. Some versions of panpsychism suggest that the entire universe might be a single, integrated conscious system. This isn't the same as saying God exists, not in any traditional sense. It's more like saying the universe itself might have an experiential dimension, that there might be something it's like to be the cosmos as a whole. This is called cosmopsychism, and it's even more speculative than regular panpsychism. But it's philosophically interesting because it might help with the combination problem. Instead of starting with tiny bits of consciousness and trying to combine them up, maybe we start with cosmic consciousness and it divides down into smaller, more limited perspectives like ours. I know this sounds mystical, but there are actual academic philosophers working on this stuff, developing formal theories, trying to make it rigorous. The point isn't that any of this is definitely true. The point is that once you take seriously the idea that consciousness might be fundamental, all sorts of possibilities open up that materialism rules out from the start. And given that materialism hasn't solved the hard problem of consciousness, given that we're still completely mystified by how subjective experience arises, maybe we need to consider these alternatives seriously, no matter how strange they seem. Let me bring this back to something more concrete. What would it mean practically if panpsychism is true? How would it change science? Well, in some ways, maybe not much. The equations of physics would still work the same. Neurons would still fire according to the same principles. But we'd have a different understanding of what those equations and principles are describing. We'd recognize that we're not just describing the external behavior of stuff, but describing the structure of experience itself. Physics would become, in a sense, a map of the relational structure of consciousness at different scales. And in neuroscience, we might approach the study of consciousness differently. Instead of asking how the brain generates consciousness, which assumes consciousness isn't there until the brain creates it, we'd ask how the brain integrates and structures the consciousness of its components. We'd look for principles of integration, patterns of information flow that create unified, complex experience from simpler experiences. This is actually closer to what researchers studying neural correlates of consciousness are doing anyway. They're looking at integration, synchronization, information processing. Panpsychism just provides a different metaphysical framework for interpreting those findings. There's also this interesting possibility that panpsychism might help with some of the conceptual problems in quantum mechanics. Now, I'm treading on really thin ice here because this gets into territory where physics and philosophy and speculation all blur together. But some interpretations of quantum mechanics have suggested that consciousness plays a role in collapsing the wave function, in determining which quantum outcome becomes actual. The usual problem with this is that it seems to require a sharp division between conscious observers and non-conscious matter, and nobody can say where that division is. But if consciousness is universal, there's no sharp division. Every quantum interaction involves experiential elements on both sides, and maybe that's what determines outcomes. The math of certain quantum theories actually looks a bit like the math of information integration, which is suggestive even if not conclusive. And here's a thought. Maybe the reason quantum mechanics is so weird, so counterintuitive, is that we're trying to describe a fundamentally experiential reality in purely objective mathematical terms. It's like trying to describe what red looks like using only equations. You can describe the wavelength of light, the neural activity it causes, but you can't capture the redness itself in equations. Maybe quantum mechanics is pointing us towards something similar. The equations work, they make predictions, but there's an experiential dimension to quantum reality that the math can't capture. And that experiential dimension is what consciousness is at the most fundamental level. I want to address one more objection to panpsychism, one that comes up a lot. People say it's unfalsifiable, unscientific. How could you ever test whether an electron is conscious? How could you disprove it? And this is a fair concern. Science works by making predictions that can be tested, hypotheses that can be falsified. If panpsychism doesn't make any testable predictions, it's more philosophy than science. But I think this critique isn't quite fair. First, panpsychism does make some conceptual predictions. It predicts that consciousness should correlate with information integration in any substrate, not just biological brains. That's testable, at least in principle. It predicts that there shouldn't be a sharp threshold where consciousness suddenly appears in evolution or development. It should be more gradual, more continuous. That's testable too. And more broadly, not everything in our best theories is directly testable. Lots of physics involves entities and processes we can never directly observe. We infer them from their effects. Maybe consciousness at fundamental levels is like that. We can't directly experience what it's like to be an electron, but we might be able to infer something about it from patterns we observe, from the structure of our theories, from the fact that consciousness clearly exists somewhere and has to come from somewhere. Panpsychism is offering an explanation. It comes from being a fundamental feature of reality, not from emerging out of nothing. You know, the more I think about this, the more I realize that the question of universal consciousness is really a question about the nature of reality itself. Are we in a universe that's fundamentally dead, fundamentally mechanical, with consciousness as a rare and inexplicable accident? Or are we in a universe that's fundamentally experiential, where consciousness isn't an accident, but an expression of reality's basic nature? Both possibilities are profound. Both have implications for how we understand ourselves, our place in the cosmos, our relationship to the rest of existence. If the universe is fundamentally non-experiential, then consciousness really is miraculous, almost magical. It means that at some point in the history of the universe, something completely new appeared, something that had never existed before in any form. Matter organized itself in just the right way, and suddenly there was experience, there was feeling, there was someone home. It's hard to overstate how mysterious that would be. It would be like saying the universe, which had only contained quantities and forces and particles, suddenly produced qualities, feelings, perspectives. How? By what mechanism? It's completely unclear. But if the universe is fundamentally experiential, if panpsychism is true, then consciousness isn't miraculous in that way. It's natural. It's built in from the start. The mystery isn't how consciousness appeared, but how it takes such different forms, how it combines and integrates and creates the rich, complex inner worlds we experience. That's still mysterious, but it's a different kind of mystery. It's more like asking how matter combines to form different structures, which is something we have some understanding of, rather than asking how something comes from nothing, which is conceptually baffling. And maybe the truth is somewhere in between. Maybe there's something we're missing, some third option we haven't thought of. Maybe consciousness isn't fully universal, but isn't purely emergent either. Maybe it arises at certain thresholds of complexity, but in a way that's more natural than mysterious emergence from nothing. Maybe the categories we're using, conscious versus non-conscious, experiential versus non-experiential, are too crude, and reality is more subtle than our concepts allow us to express. That's the thing about fundamental questions like this. The more you dig into them, the more you realize how much we don't know, how limited our understanding is. We're biological organisms that evolved to survive in a particular environment, not to understand the ultimate nature of reality. Our brains, our concepts, our intuitions, they're all shaped by evolutionary pressures that had nothing to do with discovering metaphysical truth. So maybe it shouldn't surprise us that when we ask really deep questions about consciousness and reality, we find ourselves confused, unable to choose definitively between possibilities that all seem both compelling and problematic. But that doesn't mean we should give up and say it's all unknowable. We should keep investigating, keep developing theories, keep gathering evidence, and we should stay humble, recognizing that our current understanding is almost certainly incomplete, that future discoveries might completely overturn what we think we know. That's happened before in science. Newton's mechanics seemed certain until Einstein showed it was an approximation. Classical physics seemed complete until quantum mechanics revealed a stranger reality underneath. Maybe our current materialist understanding of consciousness is like that. Maybe it works well enough for most purposes, but breaks down when you examine it closely, and we need a radically different framework. Panpsychism might be that framework. Or it might turn out to be wrong, replaced by something we haven't imagined yet. Either way, taking it seriously, working through its implications, seeing where it leads, that's valuable. It expands our thinking, challenges our assumptions, opens new avenues for research. And even if panpsychism turns out to be false, the process of examining it will have taught us something, will have clarified our thinking about consciousness in ways that might lead to the actual answer. I think one reason panpsychism seems so strange to many people is that we're deeply attached to our intuition that consciousness is special, that we're special. We like to think of ourselves as fundamentally different from rocks and rivers and robots. We're the ones with inner lives, with experiences, with consciousness. Everything else is just stuff, just matter following laws. But that view comes with a cost. It makes consciousness inexplicable. It creates an unbridgeable gap between mind and matter, and it leaves us feeling isolated, like minds trapped in a mechanical universe, fundamentally alien to the physical world we inhabit. Panpsychism, whatever its problems, offers a different vision. It says we're not alien to the physical world, we're continuous with it. The matter that makes up our brains and bodies isn't fundamentally different from the matter that makes up stars and stones. It's all experiential, all conscious in varying degrees. We're not trapped minds in a dead universe. We're complex, beautiful expressions of a universe that's alive through and through, that experiences itself in countless ways, from the simplest particles to the most complex organisms. And maybe that's right, or maybe it's wrong, but either way, it's a vision worth contemplating. Because how we answer the question of consciousness, whether we think it's universal or rare, fundamental or emergent, that shapes everything else. It shapes how we understand ourselves, how we value different forms of life, how we think about artificial intelligence and animal minds and the natural world. It shapes whether we see ourselves as separate from nature or part of it. It shapes our sense of meaning and belonging in the universe. So where does this leave us? With consciousness still mysterious, still the hardest problem in science, we've explored one possible answer, that consciousness is universal, fundamental, present in some form wherever there's integrated information. We've seen how this might solve some problems like the explanatory gap and the hard problem, even as it creates new challenges like the combination problem. We've looked at implications ranging from the ethical treatment of organisms and ecosystems to the nature of quantum mechanics and the possibility of artificial consciousness. We've considered both the appeal and the strangeness of thinking that the universe itself might be, in some sense, experiential. And through it all, one thing becomes clear: consciousness refuses to fit neatly into our categories. It's neither purely physical nor purely non-physical. It's not just brain activity, but it's somehow connected to brain activity. It's intensely subjective, available only from the inside, and yet it's part of the objective world. It's the most certain thing we know and the most mysterious. It's what makes us who we are, and yet we can't explain what it is. Maybe panpsychism is right. Maybe consciousness really is universal, fundamental, woven into the fabric of reality from the quantum level up. Maybe every particle, every wave, every field has some infinitesimal grain of experience, and what we call consciousness is what happens when these grains combine and integrate in fantastically complex ways. Maybe the universe has been conscious all along, and we're just one of countless ways it knows itself. Or maybe not. Maybe consciousness really does emerge somehow from non-conscious matter when it reaches sufficient complexity. Maybe there's an explanation we haven't found yet, a way to bridge the explanatory gap without invoking universal consciousness. Maybe future neuroscience will crack the code, will show us exactly how subjective experience arises from objective neural activity, and we'll look back at panpsychism as an interesting but misguided speculation. But even if we don't know the answer, even if we might never know for certain, the question matters. It matters because it's asking about the nature of reality at its most basic level. It's asking what the universe is made of, not just physically, but intrinsically. It's asking whether experience is a fundamental part of existence or a rare accident. And how we answer that question, tentatively, provisionally, changes how we see everything else. If I had to bet, I'd say this: consciousness is stranger than any of our current theories suggest. It's probably not purely emergent in the standard materialist sense, because that leaves too many things unexplained. But it's probably not universal in any simple sense either. Maybe the truth is more nuanced. Maybe there are different kinds or levels of consciousness, and what counts as conscious depends on how we define terms that are themselves fuzzy and context-dependent. Maybe asking, is X conscious, is like asking, is X alive? Where there's no sharp boundary, just gradations, edge cases, systems that are sort of conscious or alive in some ways but not others. Or maybe, and this feels true to me somehow, maybe consciousness is fundamental, but not in the way panpsychism suggests. Maybe it's not that particles have tiny bits of consciousness. Maybe consciousness is more like a field, a dimension of reality that everything participates in to varying degrees. Maybe it's relational, emerging in the connections between things rather than residing in things themselves. Maybe it's something we don't have words for yet, something that requires new concepts, new mathematics, new ways of thinking about the relationship between the subjective and the objective. What I do know is this: consciousness exists. You know it exists because you're experiencing it right now. And that fact, that simple, undeniable fact, has to fit into our understanding of reality somehow. It can't just be ignored or explained away. And every attempt to explain it reveals just how little we understand about the nature of existence. Consciousness might be the universe's way of knowing itself. It might be an accident, a byproduct, an emergent property. It might be fundamental, universal, the intrinsic nature of reality. We don't know. But the fact that we can ask the question, that we can wonder about our own wondering, that itself is remarkable. So here we are. Conscious beings in a possibly conscious universe, asking whether consciousness is everywhere or nowhere, fundamental or emergent, universal or rare. We're patterns of matter, asking what it's like to be patterns of matter. We're the universe, thinking about itself, experiencing itself, wondering about its own nature. And whatever the answer turns out to be, whether consciousness is universal or not, that wondering, that questioning, that experience of seeking to understand, that's consciousness too. That's the thing we're trying to explain. And maybe the fact that it's so hard to explain, so resistant to our usual methods and categories, is itself telling us something important about the nature of reality. The mystery remains, consciousness remains, and we remain conscious, wondering, experiencing every moment, living proof that at least sometimes, somewhere, the universe knows what it's like to be. And maybe that's enough. Maybe that's everything. Now let's move on to another theory for you to reflect on. I've been thinking a lot about reality lately, about what we actually experience when we look at the world around us. And it's strange, isn't it? Because we feel so certain about what we see, what we hear, what we touch. You look at a coffee cup on your desk and it seems like the most straightforward thing in the world. There it is. Solid, real, undeniable. But here's the thing, the really unsettling thing that neuroscience has been showing us over the past few decades, that coffee cup as you experience it doesn't really exist, not in the way you think it does. What you're seeing, what you're experiencing right now as you read these words, isn't reality itself. It's a construction, an elaborate, sophisticated, utterly convincing hallucination that your brain is generating for you, moment by moment, based on fragmentary sensory data and a whole lot of educated guessing. Your brain is essentially lying to you. Not maliciously, of course, but constantly, comprehensively, and with such skill that you never suspect it's happening at all. That's what makes this so fascinating and sort of disturbing when you really think about it, because we go through our lives assuming that perception is passive, right? We think our eyes are like cameras recording what's out there, and our brain is like a monitor displaying those recordings. Simple input and output. The world sends signals, our senses receive them, and we experience reality as it truly is. But that's not what's happening. That's not even close to what's happening. The truth is so much stranger, so much more complex. And when you start to understand how it actually works, it changes everything. It changes how you think about consciousness, about free will, about what it means to be you. Because if your experience of reality is an illusion, a construction, then what does that make you? What does that make anything? You see, when light bounces off that coffee cup and hits your retina, it's not carrying a little picture of a coffee cup. It's just photons, packets of electromagnetic radiation at various wavelengths, hitting photoreceptor cells in the back of your eye. These photoreceptors, these rods and cones, they convert that light into electrical signals, into patterns of neural firing. And here's where it gets interesting. Those signals don't represent a complete image. They're fragmentary, partial, actually pretty degraded by the time they leave the retina. There's a blind spot in each eye where the optic nerve exits, but you never notice it because your brain fills it in. The center of your vision, the fovea, is the only part with high resolution. Everything else, your entire peripheral vision, is actually quite blurry, low resolution, not nearly as detailed as you think it is. But you don't experience it that way. You experience the world as uniformly clear and detailed in every direction all at once. That's your brain painting in the details, creating the illusion of completeness. And it's not just vision. Every sense you have, every modality of perception works this way. Sound waves hit your eardrums and get converted into patterns of neural activity, patterns that your brain has to interpret and construct into meaningful experiences. Touch receptors in your skin fire when pressed, but the sensation of smoothness or roughness or warmth, those are constructions too, interpretations based on patterns of firing across thousands of receptors. Taste and smell, they're just chemical molecules binding to receptors, and your brain takes those chemical signatures and turns them into experiences we call sweet or bitter or the smell of coffee. None of these experiences exist outside your brain. They're internal representations, models, simulations of what's out there, generated by this 3-pound lump of tissue in your skull. But here's what really makes you stop and think. The brain doesn't have direct access to the external world. It's locked inside a dark, silent skull, receiving nothing but electrical signals from sensory organs. It never sees light, never hears sound, never touches anything. All it gets are these patterns of neural activity, these codes, these representations, and from these fragmentary, ambiguous signals, it has to construct an entire experiential world, a complete reality that feels continuous, coherent, meaningful. It has to figure out what's out there based on indirect evidence, like a detective reconstructing a crime scene from scattered clues. And the way it does this, the mechanisms it uses, they're nothing short of extraordinary. But they're also fallible. They make mistakes, they take shortcuts, they fill in gaps with assumptions, and that's where illusions come from. That's where the cracks in the construction start to show. Think about optical illusions for a moment. You've seen them, right? The ones where two lines are the same length but look different, or where static images appear to move, or where you can see two different interpretations of the same image, like that famous one that looks like either a young woman or an old woman, depending on how you look at it. These aren't just tricks or curiosities. They're revealing something profound about how perception works. They're showing us the rules and assumptions that the brain uses to construct reality, the shortcuts it takes, the bets it makes. When an illusion fools you, it's because your brain is applying its normal operating procedures, its standard protocols for interpreting sensory data, and those protocols happen to be wrong in that particular context. The illusion isn't the exception. It's a window into the rule. It's showing you that all of perception, all the time, involves these same constructive processes. It's just that most of the time, the brain's guesses are good enough that you never notice you're not seeing reality directly. Let me give you an example. There's this phenomenon called the flash lag effect. If you see a brief flash of light next to a moving object, the flash appears to lag behind the object's actual position, even though physically they're aligned. Why? Because your brain is predicting where moving objects should be. It's compensating for the processing delays in your visual system by essentially showing you where it thinks the object will be by the time you become conscious of seeing it. It's running slightly ahead of the sensory data, extrapolating into the future. That's remarkable, right? Your brain is literally showing you a predicted future, not the present. It has to do this because neural processing takes time, maybe a couple hundred milliseconds from photons hitting the retina to conscious perception. And in that time, a moving object would have moved. So the brain compensates. It guesses. And usually it guesses right, so you never notice. But when that flash appears, it reveals the trick. It shows you that what you're seeing isn't what's happening right now. It's what your brain thinks is happening right now, which is actually a prediction of the immediate future based on the recent past. And that's just one example, one small piece of the puzzle. The more you look at how perception works, the more you realize that almost everything you experience involves this kind of active construction, this predictive modeling, this filling in and guessing and interpreting. Color, for instance. Color doesn't exist in the external world. There are electromagnetic waves of different wavelengths, sure, but red and blue and green, those are experiences, qualia, created by your brain. The same wavelength of light can look different depending on context, depending on what other colors surround it, depending on what your brain expects to see. That dress that broke the internet a few years ago, the one that some people saw as blue and black and others saw as white and gold, that wasn't about the dress. It was about the assumptions different brains were making about the lighting conditions. Some brains assumed it was in shadow and compensated one way. Others assumed it was in bright light and compensated differently. Same sensory data, completely different experiences of reality. Neither person was wrong, but neither was seeing the true color of the dress, because there is no true color. There's just wavelengths of light and brains interpreting them. Now you might be thinking, okay, sure, perception involves some processing, some interpretation, but surely there's still an objective reality out there that we're getting information about, even if it's filtered through our senses and brains. And that's true, in a sense. There is something out there, something we're in contact with through our senses. But the nature of that contact, the relationship between what's out there and what we experience, it's more complicated than you might think, because the brain isn't trying to create a perfectly accurate representation of reality. It's trying to create a useful representation, one that helps you survive, navigate, act in the world. Evolutionary speaking, accuracy is less important than utility. It doesn't matter if you perceive colors correctly, whatever that would mean. It matters that you can distinguish ripe fruit from unripe fruit, that you can navigate your environment, that you can recognize faces and detect threats and find food. And this brings us to one of the most important insights from modern neuroscience, something called predictive processing or predictive coding. This is the idea that the brain is fundamentally a prediction machine. It's not passively receiving sensory data and then figuring out what it means. It's actively generating predictions about what it expects to sense and then comparing those predictions to the actual sensory input. The predictions come from internal models, from your accumulated knowledge about how the world works, from context, from memory, from expectation. And the sensory input, when it arrives, is used mainly to check the predictions, to catch errors, to update the models. It's a top-down process as much as a bottom-up one, maybe even more top-down than bottom-up. Think about reading. Right now, as you read these words, you're not processing every letter individually, building up from features to letters to words to meaning. You're predicting what words are coming based on context, based on grammar, based on meaning, and your brain is just checking that prediction against the actual visual input from the page or screen. That's why you can read text even when letters are jumbled, as long as the first and last letters are correct and the overall shape is preserved. Your brain is predicting the word, and the degraded input is good enough to confirm the prediction. That's why typos jump out at you, because they violate your predictions and create a prediction error. That's why you can have trouble proofreading your own writing, because your brain already knows what it expects to see and tends to fill that in rather than carefully checking what's actually there. And this isn't just about reading or language, it's about everything: vision, hearing, touch, your sense of your own body, your sense of time passing. All of it involves these predictions and prediction errors. When you reach for that coffee cup, your brain is predicting what it will feel like in your hand, predicting the weight, the temperature, the texture, and your actual sensory experience is largely determined by whether those predictions are confirmed or violated. When you walk across a room, your brain is predicting the feedback from your muscles and joints, the visual flow of the environment, the feeling of the ground under your feet, and it's using discrepancies between prediction and reality to maintain balance and coordinate movement. You're not consciously aware of any of this, of course. It all happens automatically beneath the level of consciousness. But it's happening constantly, millions of predictions and comparisons every second, constructing your ongoing experience of being in a body in a world. And here's where it gets really profound, really mind-bending. If the brain is a prediction machine, if it's constantly generating expectations and checking them against sensory input, then what you actually experience, the contents of your consciousness, might be primarily these predictions, these internal models, rather than the sensory data itself. The sensory data, the raw input from your eyes and ears and skin that might mostly be used for error correction, for updating the models, rather than directly determining your experience. You're experiencing the brain's best guess about reality, not reality itself. You're living inside a simulation, a controlled hallucination that's constrained by sensory data, but not determined by it. The hallucination is constantly being checked and updated to stay roughly aligned with the external world, but it's still a hallucination. It's still an internally generated model. Some neuroscientists and philosophers have started using this term controlled hallucination, and I think it's apt, even though it sounds dramatic. Because dreams, actual hallucinations, these are what happen when the control breaks down, when the predictions run without being properly constrained by sensory input. In dreams, your brain is still generating a model of reality, still constructing a perceptual world, but it's not checking that model against incoming sensory data because you're asleep. Your sensory systems are largely offline. So the dream just runs based on internal dynamics, based on memory and emotion and random neural activity. And it creates this completely convincing but often bizarre experiential reality. You don't know you're dreaming while you're in the dream because the dream is generated by the same machinery that generates your waking experience. The difference isn't in the quality or vividness of the experience, it's in whether that experience is being constrained by sensory data or not. And hallucinations in psychiatric conditions or from psychedelic drugs, those involve disruptions in the balance between predictions and sensory input, disruptions in the mechanisms that normally keep the internal model aligned with external reality. If your brain starts giving more weight to its predictions than to sensory data, if the control mechanism weakens, then you can experience things that aren't there, see patterns that don't exist, hear voices that have no external source. It's the same predictive machinery, just running in an unconstrained way, which suggests, unsettlingly, that the main difference between normal perception and hallucination is just the degree of constraint, the tightness of the coupling between internal model and external reality. We're all hallucinating all the time. Most of us are just having roughly similar, well-controlled hallucinations that happen to correspond pretty well with what's actually out there. Let me step back for a moment and talk about how we got here, how we came to understand that perception works this way, because it's not like this was obvious. For most of human history and for most of the history of science and philosophy, people assumed that perception was more or less direct, that we see the world as it is, maybe with some distortion from our sensory organs, but basically straightforward. Even early neuroscience in the 19th and early 20th centuries tended to think of the brain as processing sensory information in a bottom-up hierarchical way. Signals come in, get processed at increasingly abstract levels, and eventually you get perception, simple to complex, input to output. But there were always puzzles, always phenomena that didn't quite fit this model. The German physicist and physician Hermann von Helmholtz, working in the mid-1800s, was one of the first to suggest that perception involves what he called unconscious inference. He noticed that sensory data is ambiguous, that the same pattern of light on the retina could, in principle, be caused by many different configurations of objects in the world, so the brain has to infer to make educated guesses about what's most likely to be out there based on the sensory data plus prior knowledge. He thought of it as a kind of unconscious reasoning process, too fast and automatic to be conscious, but similar in structure to conscious inference. That was pretty radical for the time, this idea that perception isn't passive reception, but active interpretation. Then in the 20th century, Gestalt psychologists started documenting all these ways that perception seems to involve organizing principles, rules about how we group elements together, how we perceive wholes rather than just collections of parts, how context affects what we see. They showed that the brain imposes structure on sensory data, that we have built-in biases, tendencies to see things in particular ways. The whole is greater than the sum of its parts, they said, and they were pointing at something real, something about how perception is constructive rather than purely receptive. But it wasn't until the late 20th century, with the development of better neuroscience tools, with the ability to record from neurons in living brains, to map pathways to see the brain in action, that we really started to understand the mechanisms. We found that visual processing isn't just a feed-forward hierarchy, isn't just simple features being combined into complex ones as you go from retina to visual cortex to higher areas. There are massive feedback connections, more feedback than feed-forward in many parts of the visual system, suggesting that higher areas are constantly sending predictions and expectations back down to lower areas. We found neurons that respond not just to what's being seen now, but to what's expected, to what was seen before, to context. We found that attention, expectation, prior knowledge, all of these dramatically affect neural responses even in early sensory areas we used to think were just doing simple feature detection. And in the past couple of decades, this has all come together in these predictive processing theories, which try to explain all of perception, all of cognition really, in terms of prediction and prediction error. Carl Friston, a neuroscientist at University College London, has developed this framework called the free energy principle, which is mathematically quite sophisticated, but the basic idea is that the brain is trying to minimize surprise, trying to minimize the difference between what it predicts and what it senses. It does this by both updating its internal models to better match the sensory data, and by acting on the world to make the sensory data match its predictions. So perception and action are both in service of this same goal, keeping prediction error low, maintaining coherence between model and reality. This might sound abstract, but think about it in concrete terms. When you're hungry, you have a prediction that you should be eating. That creates a discrepancy, an error signal, between your predicted state and your current state. To minimize that error, you could update your model, convince yourself you're not hungry, but that doesn't work very well. So instead you go find food and eat, and that resolves the prediction error by changing reality to match the prediction. On the other hand, if you see something unexpected, something your current model can't explain, you have a choice. You can dismiss it, explain it away, fit it into your existing framework somehow, or you can update your model, change your beliefs about how the world works. Both strategies minimize prediction error, just in different ways. And the brain is constantly making these trade-offs, constantly deciding what to believe and how to act to maintain coherence. And this framework, this way of thinking about the brain, it explains so much. It explains why context matters so much in perception, why the same sensory input can be interpreted completely differently depending on what you expect to see. It explains why attention is so powerful, because attending to something is essentially giving more weight to sensory data from that source, allowing it to update your models more strongly. It explains why learning involves this balance between assimilating new information into existing schemas and accommodating, changing the schemas themselves. It explains autism, or at least aspects of autism, as potentially involving differences in the balance between prediction and sensory input, maybe giving more weight to sensory data and less to predictions, leading to a more detail-oriented, less context-dependent, but also more overwhelming perceptual experience. It explains schizophrenia as potentially involving too much weight on predictions, too little on sensory data, leading to experiences that don't match reality. But let me focus on what this means for normal perception, for your everyday experience right now. Because once you understand this predictive nature of perception, you start to see it everywhere. You start to notice how much of what you experience is expectation-driven rather than purely sensory. Have you ever been looking for your keys and looked right at them without seeing them because they were in an unexpected location? That's your predictions overriding sensory input. Have you ever misheard song lyrics, heard complete phrases that aren't actually there because your brain filled in what it expected to hear? That's top-down prediction overpowering bottom-up data. Have you ever walked into a room and forgotten why you went there? That might be related to how your brain uses environmental context to cue memories and intentions. And when you change context, the predictions change and you lose access to what you were thinking moments before. And timing, let's talk about timing for a moment, because your experience of time is also constructed, also an illusion in a very real sense. You feel like you're experiencing the present moment, like there's this clear boundary between past and future and you're living right at that boundary, but that's not actually what's happening. As I mentioned earlier with the flash lag effect, there are processing delays, significant ones. By the time you're consciously aware of seeing something, neural signals have had to travel from retina to thalamus to visual cortex, have had to be processed through multiple stages, have had to be integrated with other information, and all of that takes time, maybe 100 to 200 milliseconds, maybe more. So the present moment you're experiencing is actually the recent past. Your brain is backdating events, creating the illusion that you're experiencing them as they happen, but you're always living in the past, just a fraction of a second behind reality. Except it's even weirder than that, because your brain also has to solve what's called the binding problem. You see color in one part of the visual system, motion in another, shape in another, and all of these have different processing speeds. Motion processing is faster than color processing, for instance. So how does the brain create a unified experience where the colors and motions and shapes of objects all seem to belong together, all seem to happen at the same time? It has to bind them together. And to do that, it has to wait for all the different streams of processing to complete. And then it constructs a unified perceptual moment that includes all of them. This is called the perceptual moment, and it's not instantaneous. It might be 50 to 100 milliseconds long, this window of time that gets packaged together into a single unified experience of now. And that means your experience of the present is actually a thick slice of time, not a point, and the brain is editing that slice, arranging events within it to create a coherent narrative. There's this phenomenon called temporal binding, where if you make a voluntary action and it produces an effect, like pressing a button that makes a beep, the brain pulls those two events closer together in subjective time, making them feel more simultaneous than they actually are. This creates a sense of agency, a feeling that you cause the effect. But it's also revealing that temporal order in your experience isn't directly corresponding to temporal order in reality. The brain is rearranging, is constructing a timeline that makes sense rather than one that's strictly accurate. Or consider what happens when you move your eyes, which you're doing constantly, several times per second. Every time your eyes move, the image on your retina smears and blurs, but you don't experience that. You don't see the world jumping around and blurring every time you saccade. Why not? Because your brain edits it out. Edits. It suppresses visual processing during the eye movement, creates a perceptual gap, and then stitches together the before and after views into a continuous experience. You're literally blind for significant fractions of your waking life, but you never notice because the brain fills in those gaps, creates continuity where there is none, and it distorts your sense of time to do it. If you look at a clock with a second hand, sometimes the first moment you look at it seems to last longer than a second. That's called the stopped clock illusion. And it happens because the brain is backdating the moment you first see the clock to before the saccade, filling in the temporal gap. And that makes the first second seem to stretch. So your experience of time, your sense of now, of duration, of sequence, it's all constructed. It's all an illusion in the sense that it doesn't correspond directly to physical time. The brain is creating a subjective timeline, a perceptual narrative of events that serves your needs but doesn't necessarily reflect the true timing of neural or physical events. And this has profound implications, right? Because we trust our sense of time. We base legal testimony on it. We make decisions based on what we remember happening when. But memory and time perception are both constructive processes, both subject to all kinds of distortions and errors. Speaking of memory, that's another huge piece of the puzzle. Because memory isn't a recording. It's not like your brain has video files of past experiences stored somewhere that you can play back. Memory is reconstruction. Every time you remember something, you're rebuilding that memory from fragments, from scattered pieces of information stored across different brain regions, and you're filling in gaps, adding details, sometimes from other memories, sometimes from your current context and expectations. And the act of remembering changes the memory. Every time you retrieve a memory, it becomes labile, unstable, and when it's stored again, it can be modified, updated, distorted. So memories are not fixed records of the past, they're dynamic, constantly changing, influenced by everything that happens between the original experience and the current moment of recall. And this means your sense of personal continuity, your feeling that you're the same person who had experiences in the past, that's also constructed, also based on these reconstructed memories that might not be accurate representations of what actually happened. You are, in a very real sense, a story you tell yourself, a narrative constructed from fragmentary and unreliable memories, organized around a sense of self that is itself a construction. There's no little person inside your head, no homunculus watching the show and making decisions. There's just networks of neurons, processes of prediction and error correction, models and countermodels. And somehow all of that gives rise to this feeling of being someone, of being you. And that brings us to consciousness itself, which is maybe the deepest mystery here. Because even if we understand how the brain constructs perceptual reality, how it builds models and makes predictions and creates illusions, we still don't really understand why any of that feels like something. Why is there subjective experience at all? Why does the color red look the way it does to you? Why does pain hurt? Why is there something it's like to be you, experiencing things from the inside? This is what philosophers call the hard problem of consciousness. And it's hard because it seems like you could imagine all the same information processing, all the same neural mechanisms happening without any subjective experience, without any inner life. You could imagine philosophical zombies, creatures that behave exactly like conscious beings but have no inner experience, no qualia, no what it's likeness. Now, some people think the hard problem is a pseudo-problem, that it dissolves once you understand the mechanisms well enough, that consciousness just is the brain's modeling processes, and asking why it feels like something is like asking why water is wet. It's just what happens when you have those processes running. But other people think it's genuinely hard, that there's an explanatory gap between objective neural processes and subjective experience that we haven't bridged and maybe can't bridge with current scientific frameworks. I don't know who's right. I don't think anyone knows for sure. But what's clear is that whatever consciousness is, it's intimately bound up with this constructive, predictive modeling process that we've been talking about. Some theories suggest that consciousness is what it feels like to be a model, to be an integrated predictive model of self and world. When the brain constructs a model that includes not just external objects, but also the self as an agent, as a perspective, as something that can pay attention and make decisions, consciousness emerges. Or maybe consciousness is related to the broadcasting of information across the brain, the global availability of certain contents to multiple cognitive systems, which happens through these large-scale feedback and feed-forward connections. Or maybe it's related to the integration of information, the way different parts of the brain are interconnected and coordinated, creating a unified system that's more than the sum of its parts. These are active areas of research, and there are competing theories, different frameworks, different ideas about what matters most. But what's interesting is that almost all modern theories of consciousness involve this idea that consciousness is constructed, that it emerges from complex information processing, that it's not a passive reception of reality, but an active generation of a model, a simulation, a story. And if that's right, then understanding consciousness means understanding how the brain builds its models, how it makes its predictions, how it creates the illusion of a stable, continuous external reality when actually it's generating that reality internally moment by moment. Now let's dig deeper into how all this works mechanically, neurologically, because it's one thing to say the brain constructs reality. It's another to understand how it actually does it. And the answer involves multiple systems, multiple levels of organization, working together in incredibly complex ways. Start with the visual system, since that's the best studied and gives us the clearest picture. Light hits the retina, gets transduced into neural signals by photoreceptors. But even at this first stage, there's processing happening. There are lateral connections between retinal neurons, inhibitory interactions that enhance edges and contrasts, that start extracting features before any information leaves the eye. Then signals travel through the optic nerve to the thalamus, specifically to a structure called the lateral geniculate nucleus, or LGN. The LGN isn't just a relay station, even though it was thought of that way for a long time. It's getting massive feedback from the cortex, from higher visual areas. And that feedback is modulating which signals get passed through, which get suppressed, based on attention, based on expectation, based on current task demands. So even before visual information reaches the cortex, it's being filtered and shaped by top-down predictions. Then from the LGN, signals go to the primary visual cortex, V1, at the back of the brain. And V1 is remarkably organized. It has a map of the visual field, so neighboring points in space activate neighboring points in V1. And it has neurons that respond to specific features like edges at particular orientations or motion in particular directions. These neurons are doing feature detection, extracting basic elements of the visual scene. But here's the thing. V1 is also receiving feedback from dozens of higher visual areas, areas that process more complex features, areas involved in object recognition, spatial attention, motion processing, all of it. And the feedback connections outnumber the feed-forward connections. Most of the input to V1 isn't from the LGN, isn't from the eyes. It's from other parts of the cortex, sending predictions, sending context, sending expectations. So what V1 neurons respond to isn't determined just by the light hitting the retina. It's determined by the interaction between bottom-up sensory data and top-down predictions. The neurons are comparing what they expect to see with what they're actually seeing, and they're signaling the difference, the prediction error. From V1, information flows into two major streams, the ventral stream and the dorsal stream. The ventral stream, the WAT pathway, goes forward into the temporal lobe and is involved in object recognition, in identifying what things are. The dorsal stream, the WHERE pathway, goes up into the parietal lobe and is involved in spatial processing, in locating where things are and guiding actions toward them. Both streams have multiple areas, hierarchically organized, each extracting progressively more complex and abstract features. But it's not strictly hierarchical, not strictly feed forward. There are skip connections, lateral connections, feedback connections everywhere, creating a densely interconnected network where information flows in all directions. And at each stage, neurons are doing more than just feature detection. They're showing context effects, attention effects, learning effects. A neuron in inferotemporal cortex, for instance, might respond to faces, but its response is modulated by whether you're looking for faces, by whether you've seen that particular face before, by emotional content, by context. It's not just detecting features, it's participating in this ongoing process of prediction and comparison, of model building and error correction. And somehow, through the dynamics of this network, through the patterns of activity across millions of neurons, a coherent perceptual experience emerges, a unified visual world. But vision is just one modality, one sensory system. You also have audition, hearing, which works similarly but with different architectures. Sound waves hit the eardrum, get transduced into neural signals by hair cells in the cochlea, travel through brainstem auditory nuclei to the thalamus, and then to auditory cortex. And auditory cortex has its own hierarchical organization, its own feedback connections, its own predictive dynamics. It's building models of auditory scenes, figuring out what sounds are happening, where they're coming from, what they mean, and it's integrating information over time. Because sounds unfold temporally in a way that visual scenes don't necessarily. Speech perception, music perception, these require integrating information over hundreds of milliseconds or even seconds, building up representations of sequences and patterns and structures. And then you have touch, the somatosensory system, which processes information from receptors all over your body, receptors for pressure, for vibration, for temperature, for pain. This information goes to somatosensory cortex, which has a map of the body surface, the famous homunculus, where different regions of cortex correspond to different body parts, with more cortical space devoted to sensitive areas like the hands and lips. And again, there's feedback, there's prediction. When you reach out to touch something, your brain is predicting what it will feel like, and the actual sensation is a comparison between prediction and reality. That's why you can't tickle yourself effectively, because the predicted sensation cancels out the actual sensation when the touch is self-generated. The prediction error is minimal, but when someone else tickles you, the sensation is unpredicted, creating large prediction errors, and that's what creates the ticklish feeling. All of these sensory systems, vision, audition, somatosensation, olfaction, gustation, they're all working in parallel, all building models, all generating predictions, and they all have to be integrated somehow. You don't experience separate visual and auditory worlds. You experience a unified multisensory world where sights and sounds and touches all seem to belong together, to come from the same objects and events. And achieving that integration is non-trivial. The brain has to solve the binding problem across modalities, has to figure out which sensory signals go together, which are caused by the same events in the world. It uses temporal synchrony, spatial correspondence, learned associations, all kinds of cues to bind multisensory information into unified perceptual objects. And there are higher order areas, multisensory integration areas in the parietal and temporal cortex, where neurons respond to multiple modalities, where visual and auditory information converge, where cross-modal associations are learned and maintained. These areas are crucial for creating the sense of a coherent external world. They're also where your sense of your body in space, your body schema, is constructed, integrating visual information about where your limbs are with somatosensory feedback and motor commands. And when this integration goes wrong, when there are discrepancies between different sources of information, you can get strange experiences, illusions, distortions. There's this phenomenon called the rubber hand illusion. If you hide your real hand and put a rubber hand in front of you, and someone strokes both your real hand and the rubber hand synchronously, you can start to feel like the rubber hand is your hand. You'll even respond to threats to the rubber hand as if it were your own. That's because the visual information, seeing the rubber hand being stroked, is synchronized with the tactile information, feeling your real hand being stroked. And your brain concludes that they must be coming from the same source. It updates its body model to include the rubber hand, and you experience it as part of your body. That's how malleable the sense of self is, how dependent on sensory integration and prediction. Or consider phantom limbs, which people who've had amputations often experience. They feel their missing limb, sometimes with vivid sensations of movement or pain, even though the limb is gone. That's because the brain's model of the body still includes the limb. The somatosensory cortex still has the map, the body schema still includes it, and in the absence of sensory input to the contrary, the brain generates predictions about what the limb should be feeling, and those predictions are experienced as sensations. It's another example of perception being driven more by internal models than by external input. When input is absent or ambiguous, the model dominates and you perceive what you expect to perceive rather than what's actually there. And this is true not just for perception, but for action too, for motor control. When you move, your brain is generating motor commands, sending signals down the spinal cord to muscles. But it's also generating predictions, what are called efference copies or corollary discharges, about the sensory consequences of those movements. It predicts what you'll feel, what you'll see as a result of moving, and it uses discrepancies between predicted and actual sensory feedback to adjust the movement in real time, to maintain accuracy, to learn better motor control. That's how you get skilled at movements through practice. You're refining the internal models, reducing prediction errors, making the predictions more accurate. And this predictive motor control is intimately tied to perception. When you move your eyes, the efference copy of the eye movement command is used to predict the change in visual input. And that prediction is used to maintain perceptual stability, to keep the world from seeming to jump around. When you move your head or your body, predictions about the resulting sensory changes keep the world feeling stable, even though the sensory input is changing dramatically. Without these predictions, without this coupling between action and perception, you'd be disoriented, unable to distinguish changes in sensory input due to your own movements from changes due to the world itself moving. Now, all of this, all these mechanisms and systems, they're implemented by neurons, by networks of brain cells communicating through electrical and chemical signals. And neurons are remarkable computational devices. Each neuron receives input from thousands of other neurons, integrates those inputs, and produces an output signal, a pattern of action potentials that it sends to thousands of other neurons. And the strength of the connections, the synapses between neurons can change, can be modulated by experience, by learning. That's neuroplasticity, the brain's ability to rewire itself, to change its structure and function based on activity. And this synaptic plasticity is what allows learning, what allows the brain to build better models, to refine its predictions. When predictions are wrong, when there are prediction errors, those errors drive learning. They cause synapses to strengthen or weaken. They cause the network to adjust, to change its responses so that next time the prediction is better. It's learning through error correction, learning by minimizing surprise. And this happens constantly at every level, from low-level sensory processing to high-level conceptual understanding. Every experience, every moment of perception and action is a learning opportunity, a chance to refine the models to get better at predicting. But here's the thing, the brain isn't just learning about the external world, it's also learning about itself, about its own states and processes. It has to model not just what's out there, but also what's in here, what's happening internally. And that internal model, that sense of self, that's another construction, another aspect of the illusion. You feel like there's a unified self, a single agent experiencing things and making decisions. But actually, there are multiple systems, multiple processes operating in parallel and sometimes in competition. There's no central control, no CEO in the brain making all the decisions. There are distributed networks, coalitions of neurons engaging in complex dynamics that somehow give rise to coherent behavior and subjective experience. And the sense of self, the feeling of being someone that emerges from these dynamics. It's a model the brain constructs, a story it tells to make sense of its own activity. The self is a useful fiction, a conceptual tool that helps organize experience and behavior, but it's not a thing, not an entity that exists independently. It's a process, an ongoing construction, as fluid and context-dependent as any other perceptual experience. And that's vertiginous, isn't it? The idea that you, the feeling of being you, is just another part of the illusion, another aspect of the brain's reality construction. But let me step back and talk about why the brain works this way, why evolution produced this elaborate system of prediction and construction rather than something more straightforward. Because from an engineering perspective, you might think a simpler system would be better, more reliable. Why not just have sensory input drive behavior, directly simple stimulus response associations, without all this complex modeling and prediction? And the answer is that prediction works better, is more adaptive, especially in a complex and changing environment. If you're an organism trying to survive, you need to respond quickly to threats and opportunities, and waiting for sensory information to arrive and be processed takes too much time. By the time you see the predator, it might be too late. But if you can predict where the predator will be, based on past patterns, based on cues in the environment, you can act preemptively, you can get out of the way before it arrives. If you can predict where food will be, you can go there directly rather than searching randomly. Prediction enables anticipation, and anticipation enables efficient, timely action. And prediction also enables learning in a more fundamental sense. If you couldn't predict, if every sensory input were equally surprising, you couldn't learn patterns, couldn't extract regularities from experience. Prediction is about capturing structure, about building models of how things work, and those models are what enable generalization, planning, imagination. They let you think about what would happen if, let you consider counterfactuals, let you mentally simulate scenarios without having to physically experience them. That's incredibly powerful. That's what enables human intelligence, our ability to think abstractly, to reason about things that aren't present, to plan for the future, to learn from others' experiences. And this predictive machinery, this model-building capacity, it's not unique to humans. All animals with brains are doing some version of this, building models of their environments, making predictions, learning from prediction errors. But humans might be especially good at it, might have especially sophisticated modeling capacities, especially flexible and abstract models. Language probably helps because language lets us build models of abstract concepts, lets us think and communicate about things that aren't perceptually present. Culture helps too, because culture is essentially shared models, collective representations of how the world works that get transmitted across individuals and generations. But these models, as sophisticated as they are, they're still just models. They're useful fictions, approximations, simplifications. The world is infinitely complex, and no model can capture all of that complexity. So the brain makes trade-offs, simplifies, categorizes, ignores details. It builds models that are good enough for survival, for action, but not perfectly accurate representations. And that's fine, that's adaptive, as long as the models are useful, but it means there are always limits, always aspects of reality that our models don't capture, can't capture, maybe can't even represent. And this brings us to some of the philosophical implications, the deeper questions about the nature of reality and knowledge. If all our experiences are constructions, if we never have direct access to reality, but only to our brain's models of reality, then what can we really know? How can we be sure of anything? This is an old philosophical problem, skepticism, and the predictive processing view might seem to make it worse, to emphasize the gap between perception and reality. But actually, I think it provides a kind of answer, or at least a reframing. The point isn't that we can't know anything, that everything is subjective and arbitrary. The point is that knowledge is always mediated, always through models, but those models are constrained by reality. They have to work, have to enable successful interaction with the world. If your models are wildly inaccurate, you won't survive. Natural selection weeds out models that don't correspond well enough to reality. So while we don't have direct unmediated access to reality, we do have models that are shaped by reality, that track aspects of reality reliably enough to be useful. And science is essentially the process of systematically refining those models, testing them, comparing them, building better and more accurate representations over time. But there's still this fundamental gap, this unavoidable separation between the map and the territory. Your experience is the map, the model, and you never get to step outside it and compare it directly to the territory. You're always inside the model, always experiencing the construction. And that has existential implications. It means you're alone inside your head in a very real sense, experiencing a private simulation that no one else has access to. Other people are part of your simulation. Models your brain constructs based on sensory data, and you're part of theirs. We're all living in our own private realities, our own controlled hallucinations, and we're hoping they align well enough that we can communicate, can coordinate, can share something meaningful. And yet, despite this, despite the constructed nature of experience, despite the illusory quality of so much of what we perceive, there's still beauty, still wonder, still meaning. Maybe even more so, because understanding that your experience is constructed doesn't diminish it, doesn't make it less real in the ways that matter. The sunset you're watching is still beautiful, even if the colors are generated by your brain rather than existing in the photons themselves. The music you're hearing still moves you, even if the meaning and emotion are your own construction rather than properties of the sound waves. Love, joy, pain, fear, all of these are constructions, but they're not arbitrary constructions. They're shaped by deep biological and psychological needs, by evolutionary history, by cultural learning, by personal experience. They're real in the sense that matters most. They have causal power, they shape behavior, they constitute the substance of your life. And consciousness itself, whatever it is, however it works, is the medium through which all of this happens. It's the space in which the model exists, the screen on which the simulation plays out, and being conscious, being aware, having this inner life. It's extraordinary. It's maybe the most remarkable thing in the universe, that matter can organize itself in such a way that it becomes aware, that it experiences, that there's something it's like to be a particular configuration of atoms and molecules and cells. Whether that's explicable in purely physical terms or whether it points to something beyond current physics, I don't know. Nobody knows. But it's worth marveling at, worth taking seriously as the profound mystery that it is. Now, let me talk about some of the disorders and unusual states that reveal the machinery of perception. Because when the system breaks down or operates abnormally, we get insights into how it normally works. Neurological disorders are like natural experiments, showing us what happens when particular brain regions are damaged or when particular processes go awry. And there are so many fascinating cases, so many ways the construction can be disrupted or altered. Consider blindsight, for instance. This is a condition where people with damage to primary visual cortex, V1, report being blind in part of their visual field. They say they can't see anything in that region, but if you ask them to guess where an object is, or to reach for it, or to navigate around obstacles, they can do it. They can respond to visual information they claim not to see. How? Because there are alternative visual pathways, routes from the retina to higher visual areas that bypass V1, and these pathways can guide behavior even though they don't give rise to conscious visual experience. So you have vision without awareness, perception without consciousness. And that tells us something important. Conscious perception requires more than just processing visual information. It requires particular kinds of processing, particular kinds of integration that happen when V1 is intact, but not through these alternative pathways. Or consider hemispatial neglect, which happens after damage to the right parietal cortex, usually from a stroke. People with neglect ignore the left side of space. They don't see it, don't attend to it, don't even represent it as part of their world. If you ask them to draw a clock, they'll draw all the numbers on the right side crowded together. If you show them a picture of a house with flames coming out the left side and ask which house they'd rather live in, they'll say they have no preference, even though they consistently choose the house without flames. They're processing information from the left side at some level. It's influencing their choices, but it's not entering conscious awareness, not part of their constructed reality. And that reveals that consciousness isn't all or nothing, isn't a single unified thing. Different aspects can be dissociated, can come apart in interesting ways. Or anosognosia, which is even more striking. This is a condition where people deny their deficits, deny their disabilities. Someone who's paralyzed on one side from a stroke might insist they can move that arm, might confabulate explanations for why they're not moving it when asked. They're not lying, not being stubborn. They genuinely believe what they're saying. Their brain is constructing a reality in which they're not paralyzed. And it's so convincing that even obvious evidence to the contrary doesn't break through. That tells us about the power of the brain's models, the way they can override or ignore sensory data, and it tells us about the importance of prediction error signals. Maybe in anosognosia, the prediction error signals that would normally update the model would force recognition of the deficit are themselves disrupted, so the person is stuck with an inaccurate model that can't be corrected. Or Capgras delusion, where people believe that someone close to them, usually a spouse or family member, has been replaced by an imposter who looks identical. The person looks right, sounds right, but feels wrong, unfamiliar, and the sufferer concludes that they must be an imposter. This is thought to arise from a disconnection between face recognition areas and emotional areas. The face is recognized correctly, but it doesn't evoke the expected emotional response, the warmth and familiarity you'd normally feel. And faced with this prediction error, this mismatch between recognition and emotion, the brain constructs an explanation. This must be an imposter. It's a rational explanation for an irrational experience, and it shows how the brain is always trying to make sense of its inputs, always constructing narratives that explain the data, even when the data is misleading. And then there are synesthesias, conditions where senses get crossed, where one sensory input reliably triggers another sensory experience. Some people see colors when they hear music, or associate particular colors with particular letters or numbers, or taste shapes. These aren't metaphors, they're genuine perceptual experiences, consistent and automatic, and they reveal something about how the brain normally keeps sensory modalities separate, how it routes information to appropriate areas and prevents crosstalk. In synesthesia, there's extra connectivity or less inhibition, allowing activation in one area to spread to another, and that creates these merged or blended experiences. And that tells us that the boundaries between senses aren't absolute, aren't built into the nature of sensory modalities themselves. They're constructed, maintained by the architecture of the brain, and that architecture can vary, can be wired differently, creating different experiential realities. Or split brain patients, people who've had the corpus callosum, the main connection between the two hemispheres, severed to treat severe epilepsy. These people seem normal in everyday life, but in controlled experiments, you can show that their two hemispheres are processing information independently, sometimes even conflicting information, and they're generating separate perceptions, separate intentions. If you present a word to the left visual field, which goes to the right hemisphere, the person can't verbally report seeing it because language is in the left hemisphere, but they can point to a matching object with their left hand, which is controlled by the right hemisphere. So one part of the brain knows something that another part doesn't, and they're both in the same person. That's deeply weird. It challenges the unity of consciousness, the idea that there's a single integrated self. Maybe we're all more fragmented than we think, more collection than unity. And it's only the connections between parts, the communication and integration, that creates the illusion of a single coherent self. And then there are psychedelic experiences, altered states induced by drugs like LSD or psilocybin. These substances affect serotonin receptors, particularly the 5-HT2A receptor, and they seem to disrupt the normal hierarchical organization of brain activity, the normal balance between bottom-up and top-down processing. People report profound changes in perception, seeing patterns and connections that aren't normally there, experiencing a dissolution of boundaries between self and world, between past and present, between different sensory modalities. And recent research suggests that psychedelics increase entropy in brain activity, increase the randomness and unpredictability of neural dynamics, which might relax the constraints that normally keep the brain's models stable and coherent. The result is a more fluid, more flexible, but also more chaotic experiential reality, one where the normal rules and assumptions are suspended. And what's interesting is that these experiences, despite being drug-induced, despite being hallucinations in a sense, are often described as deeply meaningful, as revealing truths about the nature of reality, of consciousness, of self. And maybe that's because they're giving people a different perspective on the constructed nature of ordinary experience, showing them that the reality they normally take for granted is just one possible construction, one particular configuration of the brain's modeling system. It's not that the psychedelic experience is more true or more real, but it's different. And that difference can be illuminating. It can show you the machinery, the mechanisms, in a way that normal experience doesn't. And meditation, various contemplative practices, these can also alter experience in profound ways, not through drugs, but through training, through deliberate changes in attention and awareness. Experienced meditators report changes in how they experience time, self, perception, emotion, and some of these changes persist even outside of meditation. And neuroscience studies show that meditation does change the brain, changes patterns of connectivity, changes how attention systems work, changes activity in areas involved in self-representation. So you can train the brain, can modify the construction through practice, you can learn to perceive differently, to experience differently, and that tells us something about the plasticity of consciousness itself, the way it's not fixed but malleable, responsive to experience and training. All of these cases, these disorders and altered states, they're revealing the same basic truth, that experience is constructed, that the machinery of perception is complex and fragile and can be altered in myriad ways, and that understanding that machinery gives us insight into the nature of normal experience of ordinary consciousness. It demystifies in some ways, makes consciousness seem less magical and more mechanistic, but in other ways it deepens the mystery. Because even when we understand the mechanisms, even when we can explain how perception works in neural terms, the fact that it feels like something, the fact that there's subjective experience at all, remains profound and puzzling. So where does all this leave us? What do we do with the knowledge that reality, as we experience it, is an illusion, a construction? Does it matter? Should it change how we live, how we think about ourselves and the world? I think it does matter in several ways. First, it's humbling. It reminds us that our perception is limited, fallible, that we shouldn't be too confident that we're seeing things as they really are. Different people with different brains, different experiences, different contexts will construct different realities from the same sensory data, and none of them is simply right or wrong. They're all constructions, all interpretations. That should make us more humble about our own perceptions, more open to other perspectives, more aware of our biases and assumptions. Second, it's empowering, because if perception is constructed, if your experience is shaped by your brain's models and predictions, then you have some agency over that experience. You can't choose what to perceive directly, can't override sensory data entirely, but you can shape your models, can change your expectations, can train your attention. You can learn to see things differently, to experience things differently through practice, through exposure, through deliberate cognitive work. That's what therapy does. In many cases, it helps people change the models and predictions that are generating maladaptive experiences and behaviors. That's what education does. It builds better, more accurate models of how the world works. That's what art does. It offers new perspectives, new ways of modeling reality, expanding the space of possible experiences. Third, it should make us appreciate consciousness, appreciate the sheer improbability and extraordinariness of the fact that we experience anything at all. In a universe of vast, mostly empty space, of matter and energy governed by impersonal laws, there are these pockets, these configurations, where matter becomes aware, where it models itself and its environment, where it experiences and feels and thinks. That's remarkable. That's worth taking seriously, worth protecting, worth celebrating. Every conscious being is a universe unto itself, a private reality, a unique perspective on existence. And the fact that we can communicate across these private realities, can share experiences and ideas and feelings, even imperfectly, even through the veil of our separate constructions, that's extraordinary too. And fourth, I think it should inspire curiosity, wonder, a desire to understand more, because we've learned so much about how perception and consciousness work. But there's still so much we don't know. We don't know why consciousness exists, why it feels like something, why we have qualia. We don't know how neural activity gives rise to subjective experience, what the key mechanisms are, what's necessary and sufficient. We don't know if consciousness is unique to brains, to biological systems, or if it could be implemented in other substrates, in machines, in artificial systems. We don't know if animals experience consciousness the way we do, if they have rich inner lives or something simpler. We don't know if consciousness comes in degrees or if it's all or nothing, if there are different kinds or just different contents within a single kind. These are deep questions, hard questions, and we're making progress, but slowly. Every answer seems to raise new questions. Every insight reveals new mysteries. And that's exciting. That's what science is about, this ongoing process of questioning and investigating and trying to understand. And consciousness, the brain's construction of reality, this is maybe the ultimate frontier, the deepest question we can ask. What is it like to be? What is the nature of experience itself? What does it mean that there are subjects, perspectives, inner lives? And maybe we'll never fully answer these questions. Maybe there are limits to what we can understand, limits imposed by the very tools we're using, because we're trying to understand consciousness with consciousness, trying to use the brain to understand the brain. That's a strange loop, a recursive problem. And it might be that some aspects of consciousness are fundamentally beyond our grasp, beyond what can be captured in objective scientific terms. Or maybe not. Maybe we'll figure it out. Maybe we'll develop new frameworks, new ways of thinking that make it all clear. I don't know. But the journey, the process of exploring these questions, of pushing the boundaries of understanding, that's valuable in itself. And personally, individually, living with the knowledge that your reality is constructed, that your experience is an illusion in this deep sense, what does that mean day to day? Does it make life less real, less meaningful? I don't think so. I think it makes it more precious, if anything, because this construction, this private reality you're experiencing, it's all you have. It's the totality of your existence, the only world you'll ever know from the inside. And it's incredibly rich, incredibly detailed, incredibly beautiful in its complexity. Every moment of experience, every sensation and thought and feeling is the product of billions of neurons doing their intricate dance, constructing reality for you in real time. That's miraculous. That's worth paying attention to, worth being present for, worth savoring. And the people around you, the other consciousnesses, they're each constructing their own realities, their own private worlds. And somehow you're in theirs and they're in yours. And you can connect, can communicate, can share something even though you never truly experience what they experience. That's worth honoring, worth cultivating, worth protecting. Consciousness, experience, the illusion of reality, it's fragile, it's temporary. It depends on this delicate machinery that can be disrupted or destroyed. But while it's here, while you're here experiencing it, it's everything. It's the only game in town. So maybe the lesson, the takeaway from all of this isn't nihilism or skepticism or despair. Maybe it's wonder, maybe it's gratitude, maybe it's a deeper appreciation for the extraordinary, improbable, magnificent fact of experience itself. Your brain is constructing reality for you right now, moment by moment. And the result is this world, this life, this consciousness. It's an illusion, sure, but it's your illusion. It's the only reality you'll ever know. And that when you really think about it, when you let it sink in, that's beautiful. That's enough. That's everything. Because in the end, what else is there? What else could there be? We're these strange loops, these self-modeling systems, these patterns of information processing that have somehow become aware, and we're spending our brief moments of existence trying to understand what we are, how we work, what it all means, and we're making progress, building better models, refining our understanding, constructing ever more sophisticated representations of ourselves and our world. But we're always inside the construction, always experiencing the model rather than the thing itself. We never escape it, never stand outside it, never see reality as it truly is. We only ever see our brain's best guess, our controlled hallucination, our constructed reality. And maybe that's okay. Maybe that's how it has to be. Maybe there's no outside, no view from nowhere, no objective reality apart from the perspectives that experience it. Or maybe there is, but we can't access it, can't know it directly, can only ever know it through our models and constructions. Either way, this is what we have, this is what we are. Brains in skulls, building realities, experiencing illusions, and somehow finding meaning and beauty and purpose in the construction. And that's remarkable. That's worth exploring, worth celebrating, worth trying to understand as deeply as we can. So the next time you look at that coffee cup on your desk, or watch a sunset, or have a conversation with someone you love, remember, you're not experiencing reality directly. You're experiencing your brain's construction, its best guess, its predictive model. But that doesn't make it less real. in the ways that matter. It makes it more interesting, more mysterious, more worthy of attention, because every moment of experience is a miracle of neural computation, a triumph of biological engineering, a testament to billions of years of evolution producing something that can not only survive, but also wonder, question, experience, be aware. And you're part of that, you're experiencing that right now. Your brain is building the illusion of reality, and you are that illusion, experiencing itself from the inside. And that, my friend, that's something worth thinking about. That's something worth marveling at. That's something worth being grateful for, even if it's just an illusion, especially because it's an illusion, because the illusion is all we have, and it's everything.